and I'd like to thank you for attending this meeting, especially when it was raining. I have quite a lot of contents to deliver today. I'll talk about flow-based packet process framework on DPDK and VPP. So we combine all this together to create this process framework. Previously, there were two presenters, but I will represent my colleague today. First, I'd like to thank all the DPDK community and also my colleagues from Intel like John, Ray. Wang Xiang is the team leader or the project leader. Jeremy Tollett from Cisco, and Dave Berico specializes on VPP payment, and Andres and Matthews working in travel ping, and they apply this technology to 5G layer. So my agenda today, the flow-based solution and the overall picture, and then I will introduce in detail the different aspects of the solution. For example, the hardware offload and software flow process, and Hyperscan block and stream mode, and with all these elements, we have the layer 7 application, and then I will have a summary. First, why should we realize this flow-based framework? Now, the packet-based data plan process has some issues, and you find that these problems actually they're resolved separately. For a client or for a user, we cannot guarantee the order of packets in a specific flow. Thirdly, we cannot share the status among different features. And fourthly, because you cannot share the status, so some actions may be duplicated or redundant, such as the packet header hash value, and you need to calculate for multiple times, and this will occupy the CPU resources. And based on this scenario or this kind of problem, we have put forward this flow-based solution. We have two ways. One is hardware offloading, the other is through software. We have two ways of flow configuration. One is static, the other is dynamic. And the Intel new gateway, they also support flow direction. When the configuration is successful, we can use this method. If the configuration exceeds the threshold, then we need to seek the software solution. No matter by hardware offloading or software method, finally you will have this flow ID. And flow ID will be used to process the middle procedures. For example, identify the tempo. And today we will focus on the DPI. We use the flow ID to analyze the packet. For HTTP flow, we can identify But for those with encrypted paths, we cannot identify it. My colleague is also training the network model by artificial intelligence and deep learning. We use DPR or network intelligence to identify the application at T layer. Sorry, at layer 7. For example, in WeChat, you might send a text message or voice message or a video. We can use this to identify what kind of information you're sending. And based on the application, based on its route, and also its choice of route, first, I'd like to promote our E810 NIC. Compared with 710, it can provide more hardware resources and it's more flexible. And it has a QoS function. First, we can identify the by tempo. Then we can identify the brief domain information. Then by hash value, we can diverge. And this will contain flow ID or timestamp. And then we will have this pragmatic QoS, TSO. For flow configuration, we can configure static flows with 5 tempo and VRF Aware. And we can support both IPv4 and IPv6 flows. We need to first try hardware offload to NIC based on DPDK, RTE flow. So first we try the hardware offloading to configure the flow rules. If failed, then we need to create the software flow mappings. But it's a bi-directional flow, so each flow needs to create 2 hardware or software flow mappings. But both flow mappings will be mapped to the same flow. And for hardware flow offload, we use the RTE flow mechanism from DPDK. Now we have IPv4 tuple and IPv6 tuple, IPv6 VXLAN, and IPv6 VXLAN. And for the hardware flow mapping, if it matches, the flow ID will be created as a label. And then we'll create this flow ID in the packet description. If the hardware offloading fails, then we will seek to the software solution. We have the RSS mechanism, which can be utilized, and it supports IPv4 and IPv6. First, we need to calculate the hash value, and then look up the software flow table. If matched, then we need to set the flow ID to the metadata of the packet descriptor. I like to talk about the relationship between the NICs and flows. So on the left, one flow is mapping to many NICs. On the right, one NIC contains many flows. Here is strict domain and VRF Aware. If there are multiple clients, users, or enterprises connected to the NIC, maybe they share the same tuple. Maybe their, for example, destination address and the API are the same. But maybe their ID is different, then we need to identify them as different flows. And if having, for example, the same 5-tuple packet matching on two different or even on two different interfaces, they should be created as different flows as well. We just talk about the flow framework. You can apply it in the DPI process. No matter it's DPI or it's network intelligence, the process is quite similar. First, as I've mentioned, we do the hardware offloading match, and then the packets will be redirected to a DPI plugin with a flow ID. If it doesn't match, the packets will be bypassed to a DPI plugin. And then we need to look up the software flow mapping table. Because we need to deal with HTTP packets, then we need to track the TCP three-way status. For example, first we need to track the handshake. We need to ensure the connection is effective. And also it's bidirectional. Then we need to identify the traffic direction, whether it's to the client end or the other way around. Then we need to track the TCP send sequence and also its ACK sequence. Then we need to, for example, the FAN or the ACK, they will expire the flow. In DPI, one important thing is to define its database. On the left, you can see the data structure and also the matching and the corresponding application name and application ID. On the right is the ID name for the application. The first, for example, is Intel. On the left lower corner, you can see the rules. For example, Intel.com corresponds to a client system. Then how the Hyperscan works. There are two major parts. On the left, you need to match some rules. And then you need to define your block mode. Then you need to do the orchestration. And we will allocate a scratch for each flow.
And you will enter the Hyperscan and you will do the scan. If the scan is successful, then we will create a function that will tell you which matching rules you are using. There are two modes. One is block mode and TCP segments. And the roles they play for TCP segments, Reassembly. First, all the rules have to be defined within a complete payload. So if the defined rule is ABCDE, then ABCDE should be in a complete CPU payload. There are requirements for TCP segments buffer. First, there should be a buffer, and the segments should be copied first to the buffer and to deal with the overlapping part and also the desequencing part. And then we can scan the buffer and then to segment the buffer. And this is time consuming. You'll have to copy the CPU. Now that many open source projects use this Hyperscan function, but they do not have this block mode, so the performance are not good enough. So now we use the stream mode, which can be distributed in different messages. For example, we still use the rule ABCDE. For example, AB is in the first message and CDE in the second, and this will simplify the processing. With the fly, we can do a scan. And then to process the sequence, so we can do the scan and help to improve the overall process. We have realized the SSL TLS for TLS 1.2 and the previous version. So we can identify SSL and TLS certificate message in subsequent segments. And we can use these messages to identify different applications from different companies. So with the streaming processing now, so the sequence processing, we can identify this TDK message. These two messages have to be identified at the same time. So from the TCP segment, if the flow ID has been identified, then the process will be identified and the performance will be improved. So this is our test stream, and it's divided into three parts: TRS messages, and certificates, and also application data interaction. These are the test results. The timestamp, and IP and TCP and everything. So there are two important things. So the 8th message and the 9th message. So from the 8th to the 9th, there isn't any useful information, so these are captured and identified. And for the picture on the right is the same. So since it was captured on the internet, so the application ID was 7, and the graph node was PS graph node. So that's the summary for my presentation. It provides a flow-based framework, and also it's a flexible hardware uploading and software flow process. And so we support Hyperscan stream mode for the 7th layer. So that's my presentation. Do you have any questions? For the rules, how much does it occupy for one rule or two rules? So if it is precise matching, so these are similar, and it's realized through NIC. I didn't see any performance test data. So how about the performance? So it's finally down to a hard scan. The detailed performance can be tested through a test of hard scan. It can realize 10,000 streams running simultaneously. the performance is not easy to detect, but many open source softwares can generate statements and reports. Are there any notes for DPI? So many clients have already been using it. So I have a question. So you just mentioned that if the hardware fails, then we will test the software. So we will add dynamic establishment. If the hardware matching failed, then we will add a software stream. So when the next stream comes, it will first match with the hardware and then to software. And how do you know if it is successful for the hardware? Because if the hardware is succeed, then it does not go to the software. So I will check the flow ID. If it is valid, then it's okay. If it is not valid, then I will create a software stream. So two NIC have different VRF. So is there a VRF ID? So different routes will have different NICs. So there is a list giving all the information for different NICs. It's on software.
I have very question. I am moving to I have touched to DPDK, but I from the title of the presentation, by combining the DPDK and VPP,
结合 DPDK 和 VPP，
that is what the presenting right. I couldn't catch
但是
how
我不太明
to
白
select it.
我怎么样设定，
Are there any program on the
有
behalf
什么
of
项目可以来做吗？你需要去设置。
So what I should say is
那么
start with D and use CLI and type some command. Is that all?
它可以是自动生成的。
Okay, then my second question is
那么我第二个问题是，
for these 3 days we have the conference very specific to the container. And
我们
my
这2天的
expectation
会
is that
多次
VPP
谈到
and
容器
DPDK is
那么
available to the containers.
DPDK 和容器有关系吗？那么它能做很多工作，它能够把不同的工具库分开，比如说这个记忆工具库，你不需要。
So in short, it is available or in progress.
实际上我们有。
Okay, thank you.
I have a question. 815 NIC is by TCP Offload. Will it support another system? It can support all this DPDK system and protocol. But my question is, for example, other NICs, whether they could be offloaded by TC load and TC flow, or does 810 have this function as well? I think for a NIC, first it will support the inner core, then it will support DPDK. I have a question. You just mentioned the flow. You said for the following process, you would test the software and then you need to feedback to the hardware. And then when would you phase out the old flows? If we think the TCP process ends, then we need to delete it. And also, if, for example, the flow has existed for 5 minutes but there is no connection, then we need to delete it as well. Because time is up, so thank you. We can discuss other questions offline.